Okay, so guys, we've decided to record the notes today because we have some of you finishing tests, and we would like to not waste a day or lose a day and lose time on this snow day because of our classes are shorter, things like that. So we wanted to be able to record these notes so you could watch them in class and at home for reference tonight so that you could get it, because this does seem to be a little bit harder thing for y'all to understand, even though if you look at it, it's very generic in its movement. Okay, you already know about A, H, and K, so the movement of it seems to be difficult for y'all to understand, but if you look at it, it's very generic in what you know already. Okay, so today we're going to do identifying transformations. Just remember that transformations means to change or to transform. So when we're talking about all these graphs, it's technically changing or transforming from parent equation.
From the most basic form of that graph. How will it change? That's what we're looking for today.
Okay. So we're going to go back to, notice we're in vertex form.
Because of functions. Notice that we're saying f of. This applies to every function. It applies to linear functions, this applies to quadratics, and it will apply to what we're doing tomorrow, which is absolute values. These transformations apply to everything that is a function graph. That's why we're writing it in function notation.
So don't let that F throw you, okay? Sometimes y'all tend to get hung up on that F. It just means it's a function.
It's just a
function. Everything we're doing basically in Algebra 1 are functions. Okay, just about everything passes vertical line test. Okay, so we're going to go back to what you already know, which is kind of what's good, is you already know everything Miss Delk's going to write.
A is always the thing outside being multiplied, and we do know that it will either reflect up if that A value is positive, or the graph will reflect down. Notice that we're using a new terminology now. When we're talking about how will it change, we're using reflect rather than will it open up. We're saying which way will it reflect. That's a key terminology. You can't just say it'll go up, because in a minute you'll notice that that will be applied somewhere else. You can't just say it's going to up. It's going to reflect up or reflect down.
Okay. And you also know A tells you a lot about the size of things. If A is a parent, and you all know what we're already talking about, A would be equal to positive or negative 1. Remember, 1 is our perfect parent graph in math. All right, if A is narrow
or stretched,
skinny, you'll hear us we all kind of say different words. If the absolute value of A is greater than 1, you already know that. All right, technically the size would be wide or compressed. We say compressed too. If 0 is less than the absolute value of A or less than 1, meaning basically it's a fraction. Okay, you already know that.
Remember, I always like to say, think of it like a person. How much are they growing in height versus how much weight are they gaining?
And we've kind of both showed y'all that with our hands.
If we're growing more than we're gaining weight, we're going to be really tall and skinny. We're going to be narrow. If I'm growing a little but gaining a lot, I'm going to be really wide. So think of it like a person. How much are we growing versus how much are we gaining? If we do the same of each, we're going to be just like our parent, and that's not a change.
All right. Okay. That's a good little realization there. I haven't thought about it like that. All right. Now let's talk about H. Okay.
H is always inside, and it's always being applied to X. And the reason it's always being applied to X is because it is the horizontal shift of a graph. That's how it affects it, because it's the X-axis. That's why it's being applied to X. It affects which way the graph moves across the X-axis.
And you've heard Miss Delk and I apply to the H as horizontal. Remember, it should remind you H starts with horizontal, so it's your horizontal shift.
In order to figure out the horizontal shift, remember, because of that minus sign inside here, we always have to take the opposite of H to determine which way the graph will truly shift. The graph will shift left if inside.
Remember, because you're always pulling the opposite.
Positive. Because if I do the opposite, that would be a -4. So it's going to go left 4. It'll go right if inside Looks like that because we take the opposite of h. That would be a positive 4. You can't just look at it. You got to do the opposite of it to determine which way it's going to shift.
And remember, you remember that from vertex form, we always pulled the opposite of h and we kept the k. That's why the shift technically goes the opposite way.
Yep. And we're going to keep.
Okay, y'all know
K.
we always say we're going to keep the k, and we think about k's as kites, and kites float up and down in the air. Okay, we've talked about this a little bit already, but just seeing it in live is
It's known as the vertical shift. It'll either shift up or the graph will shift down. Notice this is the reason you can no longer say A is up or down. If we're talking about A, we're talking about which way it reflects. If we're talking about K, we're telling which way it shifts up or down.
And remember, we keep the k, so whatever the k value is, if it's positive 2, it's going to go up 2 on the y-axis, the vertical shift. If it's negative 2, it'll go down 2 on the y-axis. Okay, so that we can see this on a graph, and so you can see how these AH and K's change things. Ms. Delk is going to graph the original parent function.
This is the most basic we can ever be with a quadratic function. This is the original. Notice that there is an A out in front. It is 1. That means this is going to be the parent size, and it will reflect up. This is the original. There is nothing affecting X, so there's no horizontal shift. There's nothing outside for K, so there'll be no vertical shift. Quickly, I'm going to make a table of values.
And y'all know in parent form, we've talked about this, that the vertex would always start at 0, 0 in the parent form. And we're always going to start at origin. So Ms. Delk's making a quick table of values, plugging in -2, -1, 1, and 2.
Because the vertex should be 0, 0.
And then watch, she's going to graph that just beautiful parent parabola. She's going to over 2 up 4, over -2 up 4, because that's the perfect parabola right there. Perfect parent parabola. Okay, the goal of this, graphing all 3 on the same coordinate plane, is so that you can see the movements that A, H, and K do.
These are the transformations. This was the original. Now we're going to see how will they change. Okay, looking here, I have A, H, and K. We're identifying what will change, not just what will be there. So right here, A is still positive, so it should still reflect up. That's not a change, so I don't identify it as a transformation. The only thing that's changed from this A to this one is the numerical value. This one's growing 1, gaining 4, so this person is going to be very wide.
Y'all know that already. Y'all would say that is a compressed graph. So it's things you already can apply to these graphs. You just got to be able to tell them how it's changing from the original.
Okay. Next, H is our horizontal shift. I take the opposite of it. So it's technically a positive 4. And if it's positive 4, this is going to shift right 4.
On the x-axis,
Yep.
if you needed to see that. That's always your x-axis shift.
Okay. And then K is our kite. Kites go up and down. I keep its sign. It's going to go shift up 3 on the y-axis. To prove that, I'm going to create a table real quick. I'm going to put it right here.
Technically, we already know what would happen, so we could just go over there and graph it. And a lot of y'all can apply this very quickly. You know that vertex would shift right 4, up 3, and then you know about what A is going to do. But Ms. Delk's going to graph it, like show you a table and like actually graph it so you can really see it, what really happens to this graph.
So watch this. See how the vertex for the original graph was here? My new vertex is 4, 3. So right 1, 2, 3, 4, up 1, 2, 3.
Do you see how she shifted to the right 4
We
and
shifted
up 3?
from the parent, the original, and it went right 4, up 3. Next thing is this one should be wider. So we've got
5 and 3/4.
5 and 3. That's really tiny, like right there.
And then she's going to mirror it across that axis of symmetry.
And I've got 6, 4.
Okay, look how wide and compressed that parabola is. And she already knew it was going to be that way because of A. So if you look at that view, everything we said was going to happen, happened. This one became wider than our original. This one shifted right 4 and up 3 from our original 0, 0. Okay?
Okay, let's do it again. I have A, H, and K. Remember, we're identifying what will change from the original. In the original, A was a positive, now it's a negative. That is a change, so I have to identify it. This graph should reflect down. The next thing is it's a different numerical value. Instead of 1, now it's a 2. This person's going to grow 2 inches, gain a pound, grow 2 inches, gain a pound. They're going to be very narrow. Remember, H is our horizontal shift, left or right. To determine that, I had to take the opposite, which is a -1. If I'm subtracting 1, it's going to shift left 1 on the x-axis. There is no k value, so that should mean that this graph is not going to shift up or down, and it's just going to go left from this one. I'm going to really quickly make a table of values.
And she's only doing this just to prove it to y'all so you can see it, but technically Miss Delk knows what's going to happen to it. She could quickly graph it without this, but she's doing this for y'all's sake so you can see what happens. Okay, she knows it's going to open down, it's going to reflect down, it's going to get skinnier than her parent, and it's going to shift left 1.
So watch this. Here was the original vertex. My vertex is -1, 0. So that's right here. Notice that the only thing it did was it shifted left 1, just like I said it would. Then I'm going to plot all the other points. I've got 0, -2.
Oh, remember, it's getting skinnier than like she said it was going to.
And then I've got 1, -8. 2, 3. And then it should be symmetrical. Connect. Notice how it did what we said it was going to do. The transformations were true. From the blue to the green, this one reflected down. It's much narrower compared to the parent, and the vertex shifted left 1.
Okay.
So this is just proof of what we now know from looking at the equations of all functions. This applies to every function, not just quadratics, to all functions. Okay? So on the next page is identifying transformations of functions, not just necessarily quadratics. Okay, it says consider the following and describe the transformation to the graph f of x. That's the original. Remember, a is the number out in front that's being multiplied. There's an understood 1 here. There is no h inside. There is that -0 factor. There's nothing in there. There's our h. And then our k would be outside. This is the original. We're trying to figure out what's happening that's different from the original. So looking at number 4, I have A, H, and K. They only want me to identify the transformations. They want us to identify the changes. What's changing from the original to the new child graph. So look at A. A on the original was a positive 1. A on the new function is a -1. The only thing that changed was the sign. So the reflection has changed. So I would say this one will reflect down.
Notice we've kind of helped you out. We've told you the number of changes. That's what we've done with these bullet points.
We were nice.
We were nice. We're trying to tell you how many changes occur. And then we kind of gave y'all like these two to see if you could tell us how many would occur without us telling you how many bullet points is going to happen.
Notice that I'm not going to mention the size of this graph because it's the same. We're only identifying what's changing. So I've done A. Now let's move on to H. I do have an H this time. Remember, H stands for horizontal, left or right. I take the opposite. Because I'm adding 4, I would say it's going to shift right 4.
That means that whole parabola, actually that's not a parabola, but
it's a function. It could be a parabola.
The whole function would shift to the right 4.
Okay. That's all we can tell from H. K, there wasn't one in the original. Now there's a positive 2. K's are like kites. They go up and down. Because I'm adding 2, this graph is going to shift up 2.
Let's pick maybe 1 or 2 more.
Let's do this one.
Yeah, that's a good one.
So we have A, H, and notice that there is technically no kite. So there's no K change this time. Remember, we're comparing it to the original, and the original was positive, and my new one is negative, so that is a change. This one's going to reflect down. In addition, A was a 1, and now it's 7/8. This person's growing 7 inches, gaining 8 pounds. They're gaining more weight than they're growing in height. So they're going to be very wide or compressed.
Yeah, whatever word you want to use there.
That's the changes that apply to A. Then H. H was a 0. Now it's a positive 12. Remember, H is our horizontal shift. I had to take the opposite of it. Because I'm subtracting 12, this one's going to shift left 12.
On the x-axis.
On the x-axis. So this graph, whatever it was originally, if it was going up, now it's going down. It's going to be a whole lot wider, and it's going to go left 12 from the original. That would be the changes that would happen. We don't have to graph it because we know that.
Right.
Okay, let's do one more. Let's do one like this, just so you can kind of see how we would do this in our own minds. So I have A, H, and K. I'm always identifying transformations from the original. I'm constantly referring back to this. In the original, A was 1, and now it's a positive 3. So its sign did not change. The only thing that did was the numerical value. That means the size changed. This one was parent. This person's growing 3 inches, gaining a pound. They're growing more than they're gaining weight, so they're being tall and skinny. We call that, though, in math, narrow.
Or stretched.
Or stretch.
You're going to hear both. We don't know, but just
On the
know
EOC, they may ask for either one there. We don't know. It just depends on what they like. Okay, next thing, there was no H, and now I have a positive 9H value. Remember, H is horizontal, left and right. I take the opposite. If I'm subtracting 9, I have to say it's going to shift left 9.
And that would be on the x-axis.
X-axis.
Yeah.
Then we're going to compare K's. There was no K. Now I've got a positive 10. K's are like kites. They go up and down. I keep K. So this one's going to shift up 10. And if they asked, it would be on the y-axis because kites are up and down. That's a vertical shift.
Okay, so we left you these 3. We're telling you how many changes should occur, okay? So we're seeing, that's what the bullet points mean. This one should have 2 changes. This one should have 1. We want to see if you can do this without knowing how many changes occur.
And then you've got some more practice right here.
Okay.
Notice that we're comparing it to the original. We gave you lots of help on these.
And
In
then,
order to get your homework, you have to complete this, bring it to us so we can check it. Once we agree with you, you may then work on your homework.
is there some on the back?
Nope.
No, okay. So we
That's
only
it.
gave y'all
It's not too
15.
bad.
There's 18, and they're not hard. So just, they can go pretty quickly. Let us check your homework, or let us check this classwork, and then we'll give you your homework.